So today we will discuss about projectile and projectile motion. So what is projectile? What is projectile motion? Under projectile motion, we will calculate trajectory of the projectile, maximum height, time of flight, and horizontal range. First, we will discuss what is projectile. So projectile is an object which is propelled into free space with the initial thrust. Once it is in the free space, no more propelled, it is no more propelled or no external force is applied by fuel or any external agency other than gravitation on it throughout its motion. So this is projectile. Only once the initial thrust or propulsion will be applied to the object and it is propelled to the free space. During its motion, no more external force other than gravitation will be applied to the object. So this type of objects are termed as projectile, and motion of this projectile is known as projectile motion. So in this class we will discuss what will be the trajectory, that is path of the projectile. In which path if projectiles will travel if propelled into free space. Next, what is the maximum height it can achieve during this motion? Okay. What is the time of flight for this projectile and horizontal range for this projectile? So let us discuss about some examples of projectile. A cricket ball thrown by a fielder into space. He has applied an initial thrust. After applying the initial thrust, the cricket ball will travel in a projectile motion. He has no more control on the ball. He cannot change his trajectory once propelled into the free space. It is freely moving under gravity. He cannot change his path midway. So this is an example of projectile. A football kicked by a player, he will apply an initial thrust or force into the ball and the ball is free to travel in the free space under gravity. He has no more control or he cannot apply any external force further in his path. So this is an example of projectile. A bird flying in sky, can it be a projectile? An aeroplane flying in the sky, can it be a projectile? These two cannot be a projectile because the propulsion or thrust is applied throughout the motion. Aeroplane is applying thrust in this motion. Similarly, bird is applying thrust in this motion. So they cannot be a projectile. A javelin thrown by a javelin thrower, is it a projectile or not? Yes. Only initial thrust or force is applied throughout this motion. It has no external force other than gravitation. So these kind of objects which are thrown into free space by applying an initial thrust or force and no further control or external force is applied other than gravity. Only gravity is the force applied on the body. It is free to move on the gravity. No more external control is there. So these type of objects are known as projectile. So first our job is to identify whether it is a projectile or not. If it is a projectile, this motion will be termed as projectile motion. In the expressions derived by us will be applied to the object. If an external force is applied midway, we cannot apply these expressions which we are going to derive to that particular body edge, it is not a projectile. Okay, only for projectile we can apply these expressions which we are going to derive. So next, so let us discuss. So let us discuss trajectory or path of the projectile path. So what will be the path of the projectile? We have seen cricket matches, we have seen football, we have seen javelin throw. So what is the path of the projectile? These are examples of projectile. We have seen this and we have observed that normally if it is a ground, suppose this horizontal line represents surface and a projectile is projected from point O from this surface. Suppose it is projected at an angle theta with surface or ground. Suppose the projectile is projected with an angle theta with horizontal with an initial velocity u. It will try to move along this direction in linear direction according to equation of first law of Newton's law. First law of Newton's law of motion. It will try to move in this straight line, but gravitation is pulling it down. Gravitation is trying to pull it down. So it will exert a force. Initial force is in this direction, but gravitation is along downward direction. So it will follow a path in resultant direction through vectors, which are one is along theta with horizontal, one is downward is acting on the projectile. So the resultant force will be along this direction. So the path of the projectile will be this. Suppose this is the maximum height achieved by the projectile. In this direction, this is the force and this is the gravitation. So it will follow a resultant path. So this looks like a parabola. This shape is parabolic in nature. So path of a projectile is parabolic in nature. It will reach the ground at suppose point B. Point B. So what is the path of the projectile or trajectory of the projectile? This is parabolic in nature. This is parabolic in nature. We have three important points, that is the point from where the projectile is projected into free space. What is the characteristics of this point? At point O, the angle of projection is theta degree with horizontal or theta radian with horizontal. Angle is theta. It is projected with the initial velocity u. It is projected with initial velocity u. Since gravitation is applied and acceleration due to gravity. Acceleration due to gravity. Acceleration will change the velocity. Acceleration will change the velocity. Since acceleration is there, velocity will change. Whether the velocity will increase or decrease, but change will be there. Since acceleration is there, velocity will change. Velocity may increase, velocity may decrease. From O to A, from O to A, acceleration is applied against the motion. Acceleration is applied against the motion. The object is trying to go up, but acceleration is pulling it down. It is in opposite direction. So velocity will decrease. Velocity will decrease. Someone is pulling you from behind. Your velocity will decrease. Someone will pushing you from behind. Your velocity will increase. So this is the phenomenon. Since gravitation is acting against the motion from O to A, it is trying to go up, but gravitation is pulling it down. So the velocity will decrease. At point A, it is trying to go down. Acceleration is pulling it down. So velocity will increase. At maximum height point, velocity is vertical velocity is 0. Vertical velocity is 0. We will discuss what is vertical velocity, what is horizontal velocity. This is an example of motion in a plane. Motion in a plane. We have discussed motion in straight line, motion in a plane where 2D will be applied, motion in 3 space where 3 dimension is required. This is motion in a plane. So 2 dimensions will be there. One is x horizontal direction, one vertical direction. So as we have discussed for motion in a plane, the equation of motion components will be divided into horizontal and vertical. Suppose at this point, 2 components are there. Velocity is v. At point A, the velocity is v. So it will have 2 components. One is vx, one is vy. X is the velocity along the horizontal direction. Y is the velocity along. Vy is the velocity along vertical direction. Similarly, at initial point U, there will be 2 components. One is horizontal component, one is vertical component. Since the angle is theta, we know how to calculate the horizontal component and vertical component. From here, we have to draw a perpendicular, and here cos theta will be v by h. This value is u, so this value will be u cos theta. Cos theta equals to this value ux by u. So ux is u cos theta. Similarly, sin theta is p by h. So this is uy by u. So uy is u sin theta. Always remember, theta is the angle with horizontal and u is the vector. Suppose any vector. Here u is initial velocity. The horizontal component will always be u cos theta. Vertical component is u sin theta. If theta is the angle with horizontal. Horizontal component will be u cos theta. Vertical component will be u sin theta. Suppose we take a random point P. Whose coordinates are x, y. As we have discussed, at any point for a non-linear motion, the direction of linear velocity will be tangential. So at this point, the velocity will be along tangent. So it will have 2 components. One is horizontal component, one is vertical. So what is Vx and Vy for this point? What is Vx and Vy for this point? It is varying since it is a motion under gravity. Acceleration is applied throughout the motion. At no point velocity will be same. Velocity will vary continuously. From O to A, if we consider, the velocity will decrease. It will be minimum at A. And it will increase from A to B. At point know that it will achieve the initial velocity. It will achieve the initial velocity. From how to understand it? Suppose I am propelling this chalk into space. It is going to a maximum height where the velocity is 0 for this case, that is minimum, and while going down it accelerates. It accelerates under gravity. Velocity increases. First, while going up, the velocity continuously decreases. At maximum height, it is minimum velocity. For this case, it is 0. While going down, the velocity increases. At the point where it reaches the same point where it has been launched, the velocity has been achieved. The same velocity has been achieved. See, suppose I have propelled this chalk from this point with velocity 5 meter per second. It will go to a certain height, maximum height. The velocity at this point will be 0 meter per second. While coming down, at the same point of propulsion, it will achieve the same amount of velocity, that is 5 meter per second. This is the property. This is the property. So we will see at this point also the velocity will be the initial velocity. Throughout the motion, the velocity varies. So we have 4 important points where we want to calculate the parameters of motion. What are the parameters of motion? Time, displacement, velocity, acceleration. These major parameters we are calculating throughout our study. First thing is, what is time? How much time has been taken by the object to reach these points? What is the displacement? What is the displacement to reach these points? What are the velocities at this point? What are the change in velocity? What is the rate of change in velocity? All these parameters. The rate of change of velocity is acceleration. Okay. Change in position, displacement. Rate of change of position, velocity. So these parameters have to be calculated. We are studying these parameters only. Time, displacement, speed or velocity, acceleration, then finally force. Time, displacement, velocity or speed, acceleration and force. For kinematics, we are not bothered about force, we are bothered about these four. In mechanics, we are bothered about force. When you study mechanics, it will be in terms of force only, in terms of force only. But in kinematics, we are not bothered about force, we are bothered about rest for physics parameters. Okay. So, what are the? We can draw a table to know what are the values of these parameters in these 4 important points. We have 4 important points. Point of propagation, that is O. P is a random point in between the motion we have taken. A is the point where maximum height is achieved. Maximum height means from ground, this is the maximum height. B is the point where it reaches ground again. So this diagram we have to remember, and for our understanding will represent these data into a tabular form so that we will understand what happens. So what are the parameters? First parameter is